Good morning to all. My name is E.R.Vishnu Vardhini. I am Assistant Professor in Computer Science and Technology. Okay. Now we are going to say a new one, that is case study on n-quains problems. In n-quains problems, there are 2 cross 2, 4 cross 4, 8 cross 8 are there. Now we take 8 cross 8. The goal of the 8 queens problem is to place 8 queens on the chessboard such that no queens attack any other. A queens attack any piece in the same row column on the diagonal. Another solution that fails, the queen in the rightmost column is attacked by the queen at the top left. So this is the chessboard and this is that 8 queens problem. There are 8 rows and 8 columns. The first queen, the first coin is placed in the first row in fourth column, and the second queen is placing where we can place here, 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 and anywhere. I'm going to place the second queen here. Okay, where there are no rows, columns, and the diagonals also. So now I am placing here the second queen. The third coin I am placing here, the third row in the eighth column. So there are no rows, columns, and the diagonals. And then fourth coin. So fourth coin, see that there are no rows and then no columns. So I am placing the fourth coin here. The diagonals also. See the diagonals? No. So I am placing the fourth coin here. And fifth coin, where are we placing the fifth coin? Here having the diagonal, here also having the diagonal, here rows, and then no columns only having. So here I am placing the fifth coin, and then sixth coin. See, here the sixth coin. I am placing the sixth row on the first column. The sixth coin have been placed. So there are no rows and the columns. So seventh coin, seventh one. So no rows on the columns, the diagonals also not having here. So I am placing the seventh queen here. And then the eighth queen. The eighth queen I am placing here at the last. So there are no rows and the columns. So these are the 8 queens problem. We are placing the 8 queens in the chessboard, and that there are no other possibilities means we have to go to the backtracking method to place the 8 queens. Compulsory 8 queens are placing in that chessboard. Okay. Next, although efficient special purpose algorithms exist for this problem and for the whole n queens family, it remains a useful chess problem for search algorithms. There are two main kinds of formulation. Two main kinds of formulation. The one is an incremental formulation. Incremental formulation involves operators that augment in state description starting with an empty state 8 queens problem. This means that each action adds a queen state. The second one is the complete state formulation. A complete state formulation starts with all 8 queens on the board and moves them around. In either case, the path cost is of no interest because only the final state counts. The first incremental formulation one might try is the following: states, initial state, action, transition, and the goals test. States, any arrangement of 0 to 8 queens on the board is a state. Initial state, that is 0, no queens on the board. Actions, yeah, add a queen to an empty square. Transition, that is add a queen in the empty square is the transition. Sorry, add a coin to an empty square is the action. Transition means returns the board with the coin added to the specified state. That is we are that is not possible state means we go to the backtracking method. No, that is the transition. Go to backtracking method to traverse and travel and then we place the coin. No, so that is the transition. Goal test. 8 coins are on the board. There is none attack. Well, there all the 8 coins are placed under the 8 rows and the 8 columns. That is the goal test. அதாவது ஒரு ரோ ஒரு காலம்னா அந்த coin வந்து பிளேஸ் ஆயிருக்குது இல்ல, ஸோ அதை தான் வந்து கோல் டெஸ்ட், அதுதான் நம்மளோட கோல். ஸோ அதுதான் கோல் டெஸ்ட்டை கொடுத்துருக்காங்க. ஓகே, in this formulation we have 64, 63, 57 is approximately 1.8 into 10 to the power 14 possible sequences to investigate. A better formulation would prohibit placing a coin in any square that is already attacked. So that states all possible arrangements of n coins 0 less than n is less than 0 less than or equal to n is less than or equal to 8. 1. Per column is the leftmost n columns with no coin attacking another. Actions: add a coin to any square in the leftmost column such that it is not attacked by any other coin. Thank you. So we solve a problem under this n coin problem. So this is the session was over. Thank you for your cooperation.